resonant frequencies of the rest of the instrument, they act as a filter on top of the vibration of the strings, so they can also go into shape. It's not a strong effect, but it is an effect there. So then the last thing I want to talk about before we talk about the instrument that we'll put together is I brought what I call my exploded guitar, because I started taking it apart. I think I got this at a garage sale, and I think I overpaid it at $5, even though it was all together when I got it. But I wanted to know more, and I still want to know more about this little piece here, the truss rod. The truss rod is something that we're not going to use in the instrument we build tonight, but the main parts of the instrument here are, the body. You have the top plate, back plate. There's ribs that gives support to the top plate. The bridge is down here, and then there's a neck which is supported by the truss rod. So the truss rod adds rigidity to the neck, because when the fretboard goes on top of it, you can tell it's been a long time since this has actually been in here. But when the fretboard, here's the fretboard goes on top, and then the strings are strung across, there's an incredible amount of tension. So this truss rod's job is to keep the neck attached to the body. And what's interesting to me about it is how the luthier can adjust the angle of the neck by adjusting the really the tension in the truss rod. So then the only other thing that we really need to talk about with this is how are the frets placed. So you notice at the closer to the end of the neck, up by the headstock, the frets are spaced further apart. As you get closer to the bridge, they get closer together. All right. So it turns out that if you'd like to have a Western scale where the octave, which is the 12th semitone up, is 1/2 of the length. So there was our octave. Okay, if you want to do that and then fit, all your notes in between, that you have to change the length by a factor which is the 12th root of 2. Right? So if we have, if we double the frequency, that's where the 2 is, and we want to fit 12 notes in, that's where the 12th is. That's the factor that we have to change by, and that equals about 1.059. It's an irrational number. It's but it's approximately equal to 18/17. All right. So if you put your fret 1/18 of the remaining distance to the bridge, your fret will be really, really close to the right spot. All right. So for your first fret, you take the distance from the nut to the bridge. 1/18 of that, that's how much you have to come in to set your first one. Then the distance from that first fret to the bridge, 1/18 of that distance, that's how much further you have to inset your bridge, or your fret, if you want to have a standard tuning. Okay, so now I'm going to point out my cigar box guitar, which I sort of posted a blog about, and it's still not quite done. I had originally decided that I didn't necessarily want frets on mine because I wasn't necessarily sure I wanted to, whatever sort of scale to be locked into, or I wanted to play around without any frets, just see how it worked. But I could put frets on here. But you guys have seen that there are design issues. The action is quite high because and the main difference between this cigar box guitar and the cigar box guitar featured in the Make magazine is that I wanted my top plate to be the bottom of the cigar box, all right, because I wanted the exposed wood instead of the decorated side. And I also wanted to, as closely as I could, mimic the the action of the top plate of the guitar. And so I wanted my top plate to be as free to vibrate as possible. Mm-hmm. So what I had tried doing is not putting the extension of the neck right onto that top plate. All right, and I wanted that to be able to freely vibrate, so I could couple the vibrations. I mean, this bridge is not a final bridge. I want a much smaller bridge, but the idea was that it was supposed to push on a freely floating top plate, just like the guitar. Yeah. The design in the Make magazine, first of all, it uses the hinge side, and what they do is they essentially put that neck right along the top, and then screw it into there, so that you have. I mean, it kind of works as a bracing running all the way down. Sure. But my thought was maybe that will take away a little bit of the sympathetic vibration action of the coupling of the strings to the bridge to the top plate. So that was the reason that I chose to do it the way that I did it. The problem with the action notwithstanding, I think that's something that I can hopefully, compensate for, and it's going to take me a little bit longer to compensate for that than I had originally thought. So, I have lots of stuff here for us to put together other cigar box guitars. It actually went together incredibly fast with our tools that we got here. I was really happy with how fast it went together, not having ever looked at the actual instructions for how other people have done it. So, questions, thoughts,
I don't think so.
Comments, anything I didn't talk about that we should?
No, coming in, I was wondering about how the tension of the string factored into the pitch, but that makes a lot of sense.
Yeah. So it's, I mean, if you well, of course I erased that part, but it's really kind of the wave speed is what change the tension changes the wave speed.
Yeah, right.
Okay.
And based on the
but yeah, your F is N to L, right? Mm-hmm. Where N is whatever resonant frequency you want. So the frequency is directly proportional to V. So you might as well just substitute, square root of T over that. Yeah. So if you put in a heavier wire, the frequency's got to go down. Right. If mu goes up, F goes down. If you crank on it, T goes up, then F goes up, and your notes get sharper.
Yeah, the velocity, that was the key, because I was from the wind instrument class. I was thinking velocity is pretty much fixed.
In the wind instruments, the velocity is definitely fixed, but yeah. But there are connections, because we use the same basic equation, V equals F times lambda, and then a lot of these expressions. Well, this expression is exactly the same for the pipe open at both ends. Right. So, But in that case, V does stay fixed, and so yeah. Yep. There's a lot of connections there.